Number 15, it's a rational function. Given my function, find the vertical asymptote. The vertical asymptote is what's not allowed. So the vertical asymptote is going to happen when I'm dividing by 0. That happens when 2x is -1. So when x is -1/2. That's my vertical asymptote. B, they want to know where the horizontal or other asymptote is. So we look at the degree of the top and the bottom. It's the same. So the degree is just going to be it's going to be a horizontal asymptote, and it's going to be at the ratio of the lead coefficients. 8 divided by 2, y equals 4 is the horizontal asymptote. I use AT for shorthand for asymptote. The zeros of the function are when the numerator is 0. So when 8x minus 3 is 0. So when 8x equals 3. So the 0 is x equals 3/8. I'm going to go ahead and draw this. Okay. I've got a vertical asymptote at x equals -1/2. So I draw a dotted line through x is -1/2. I've got a horizontal asymptote at y equals 4. So I'm going to draw a dotted line at y equals 4. I've got a 0 at 3/8. So that's +1. 3/8 is about here. And then sketch. D asks for a sketch. Well, I like to include the y-intercept. So that's the function's value when x is 0. So 8 times 0 is 0 minus 3 over 2 times 0 is 0 plus 1. So it's -3, 2, 3. So it's going to go like that to that. I've got a vertical asymptote here, so it's going to approach there. And I've got this horizontal asymptote here, so I know it's going to approach there, then flatten. And on this side, my graph can't be on the bottom because then it would have to cross the x-axis. So it will be here. And I can use my calculator to check. Just please make sure that you put the numerator in parentheses, 8x minus 3, divided by quantity 2x plus 1. So zoom, let's do zoom 4. Then you'll see a nice, the bottom curve. Zoom 6 is better for the whole thing. See that horizontal asymptote? It's going up and coming back down. And again, you see the graph is, the calculator is not a good way to graph these things. By hand, you get much better graphs.